Hello everybody. So in this particular video, we'll be starting the second part of second module, which will be friction. The first part was, which we went through earlier, was equilibrium of forces. It was equilibrium, the concept of equilibrium. So we have completed the concept of equilibrium and we'll be starting the concept of friction today, which is the second part of second module. Let us try to understand the concept of friction. Friction is also called as frictional resistance offered by a particular surface when a body is in contact with the surface. Let us try to understand this in detail. So let me consider, in order to understand the concept of friction, let me consider a body. And this particular body is in contact with the surface. So body is in contact with the surface. This is the body and this is in contact with the surface. So whenever a body is in contact with the surface, you know how to mark the hidden forces. As far as a body which is in contact with the surface is concerned. So these are the hidden forces. If I draw the coordinates in this way, this is the x-axis, this is the y-axis. The first hidden force what you can mark is the self-weight. Self-weight will act vertically downwards. Self-weight of the body will act vertically downwards. We are discussing this in general. In order to understand the concept of friction, we are discussing this in general. So whenever a body is in contact with the surface, we can mark all the hidden forces. The first hidden force will be self-weight, which always moves vertically downwards. And the second hidden force, when a body is in contact with the surface, when the body is in contact with the surface, it is just in contact with the surface. Surface offers a reaction. Which is always perpendicular to the surface, directed towards the body. It acts exactly at the point of contact. We call that reaction as normal reaction. So this is the reaction offered by the surface on the body when the body is in just contact with the surface. If the same body, now this particular body is stationary. And it is just in contact with the surface. Now if the same body, if it tries to move either horizontally to the right or horizontally to the left, if it tries to move, till now we were not considering body under motion, it was just in contact with the surface. Now body is in contact with the surface, but the same body, if it starts to move either horizontally to the right or horizontally to the left, the surface offers one more resistance or reaction, or one more force, which offers resistance to the motion. If it tries to move, you'll find one more hidden force offered by the surface itself. Normal reaction is offered by the surface. When the body is in contact with the surface. If the same body starts to move, either horizontal to the right or horizontal to the left, but the surface offers one more reaction. And that particular reaction is called as frictional resistance or frictional force. We call that particular reaction as frictional force. So this particular force, frictional resistance, arises only when the body moves. Over the surface. If it is just in contact with the surface, if it doesn't move, then there will be no frictional resistance. And if the same body attempts to move, starts to move, or if there is an external force which tries to pull the body, then there arises another force offered by the surface along with normal reaction. Normal reaction is offered by the surface, and even the frictional resistance is also offered by the surface. So how to mark a frictional resistance? Now normal reaction is always perpendicular to the surface and directed towards the body. Normal reaction will always be perpendicular to the surface and directed towards the body. Now how to mark frictional resistance is the question. So frictional resistance is also offered by the surface. Now if the body moves horizontally to the right, then the frictional resistance should be acting in a direction opposite to the direction of motion of the body. Frictional resistance will be acting horizontally to the left. We mark it as F. Frictional resistance will be acting horizontal to the left, and the frictional resistance should always be tangential to the surface. Normal reaction will be perpendicular to the surface, whereas frictional resistance will be tangential to the surface. Frictional resistance will always be tangential to the surface, and it will be acting in a direction opposite to the direction of motion of the body. So if the body moves horizontal to the right, then the frictional resistance will be acting horizontally to the left, and this frictional resistance will be tangential to the surface. It will be tangential to the surface. Similarly, if the body moves horizontally to the left, then frictional resistance will be acting horizontally to the right, and it will be tangential to the surface. So here surface offers two reactions, whereas still the previous case, in the previous part of equilibrium, we were not considering the motion of the body. Body was assumed to be stationary or under equilibrium. So that's why this frictional force was not considered. Now here the body moves either horizontal to the right or horizontal to the left. So you have to mark the frictional resistance as well. Or you know how to mark normal reaction. Normal reaction will always be perpendicular to the surface. Normal reaction will always be perpendicular to the surface, whereas frictional resistance will always be tangential to the surface. Frictional resistance will always be tangential to the surface. Since the frictional resistance is tangential to the surface, frictional resistance and normal reaction are mutually perpendicular. Now, the direction of frictional resistance always depends. on the direction of motion of the body. So if the body moves horizontally to the right, then the frictional resistance will be acting horizontal to the left. If the same body moves horizontal to the left, then the frictional resistance will be acting horizontally to the right. This is how it goes. Now let us try to understand the concept of friction in detail. So this is the definition of friction. Which we discussed just now. So whenever a body moves or tends to move over another surface, a force which opposes the motion of the body, or opposite forces developed tangentially at the surface of the contact, or surface offers a tangential force which is opposite to the direction of motion of the body. The body tries to move horizontally to the right, then the opposite motion offered by the surface will be opposite to the direction of motion of the body. If the body moves horizontal to the right, then the frictional resistance will be acting horizontally to the left. And if the body moves horizontally to the left, frictional resistance will be acting horizontally to the right. That's what is given here. Tangentially at the surface of the contact, such an opposing force is developed, and that particular force is called as frictional resistance. This is the definition. First of all, you have to understand the meaning. So whenever a body is in contact with the surface, and if the same body tries to move over the surface offers an opposite force, or an opposite force, which will be in a direction opposite to the motion of the body. If the body moves horizontally to the right, frictional resistance will be acting horizontal to the left. If the body moves horizontal to the left, the frictional resistance will be acting horizontal to the right. Such opposite force is called as frictional resistance, or that opposition is called as friction offered by the body. Now, let us consider the same example. Let us try to consider the same example. I'll consider a body. Which is in contact with surface. Body which is in contact with the surface. Body of self-weight W. So self-weight will always act vertically downwards. So whenever a body is in contact with the surface, surface offers a reaction. And that reaction will be normal reaction. Surface offers a reaction, that reaction will be normal reaction, and normal reaction will always be perpendicular to the surface. Let me introduce an external force here. P, and let this external force P push the body horizontally to the right. Because of the external force, now the body moves horizontally to the right. Because of the external force. It's not compulsory that body should move in the direction of external force. You have to remember this. So it's not compulsory that body should move in the direction of external force. Now here let us consider that external force P pushes the body horizontally to the right. Pushes the body horizontally to the right. So when the body moves horizontally to the right, how can I mark the frictional resistance? Frictional resistance will be horizontally to the left. And it will be tangential to the surface. And it will be tangential to the surface. These are the forces which I can mark. These are the forces which I can mark as per the given slide. You can observe the slide here. You're asked to consider a body of weight W resting on a surface and which is subjected to an external force P. And let us go through the last point here. The body can start moving or slide over the plane if force P, external force P, overcomes the frictional resistance F. If external force P overcomes the frictional resistance F. This is what is given here at the end. Now let us try to understand this particular concept. Now you have two forces, P and F. You have two forces. P is the applied external force and F is the frictional resistance offered by the surface. F is the frictional resistance offered by the surface. Now, let us assume that this particular body is stationary enough. Is stationary. It has not started moving. It's still stationary. Now, let me increase the magnitude of external force a bit. Let me increase the magnitude of external force. Let me push. Let me increase the magnitude of external force. So when I increase the magnitude of external force, the magnitude of frictional force also increases simultaneously. So initially let a body be under rest. I'll consider this as a body and let this body be under rest. This is stationary now. Now I'll introduce an external force. And I'll start increasing the magnitude of this external force. So even though I apply an external force, body doesn't move. Body stays stationary because the resistance offered by the surface, the frictional resistance also increases proportionally. So as I increase the magnitude of the external force, the magnitude of frictional resistance also increases proportionally. So because of this process, body will not move. But I want to move the body. So I'll increase the magnitude of external force still. So when I do this again, the friction resistance increases. But still I want to move the body, I'll increase the magnitude of external force. What happens to friction resistance? Even this increases. So if this process continues, as I increase the applied force, if the frictional resistance continuously gets increased proportionally, body can never move. So if this process continues, body can never move. But this body has to move, is it not? This body has to move. Therefore, this process continues till a particular point. And after that particular point, frictional resistance cannot increase as you increase the magnitude of external force. At this particular point, this external force overtakes frictional resistance. External force overtakes the frictional resistance and body will start moving. So this is what you're supposed to understand. Till a particular point, as you increase the external force, even the friction resistance offered by the surface increases proportionally. As you increase the applied external force, even the frictional resistance offered by the surface increases proportionally. So this process continues till a particular point, above which, even though you increase external force, friction resistance will not increase. So when force reaches this particular point, the applied force overtakes the frictional resistance, or it becomes more than the frictional resistance, and then the body starts to move. That's what is given here. That's what is being mentioned. The body can start moving or slide over the plane if force P overcomes the frictional resistance F. That is what is given. You can see in the slide. Done. So hope this particular concept is clear now. So when you increase the magnitude of external force slowly, as you increase the magnitude of external force, even the magnitude of friction resistance increases. What happens if this process continues? Body can never move. So since body wants to move, this particular process continues till a particular point. And after that particular point, even though you increase the magnitude of external force, magnitude of friction resistance cannot increase. It cannot increase. So when it cannot increase, this applied force overtakes the friction resistance. When it overtakes the friction resistance, body starts to move. This is a simple concept which you're supposed to understand. And that particular point till which this process continues, that particular point till which this process continues, as you increase the magnitude of external force, if the magnitude of friction resistance increases, that particular point till which it increases is called as limiting friction point. Is called as limiting friction point. Is called as limiting friction point, which is very, very important. So what is limiting friction point? It is a point. It is a point till which as you increase the external force which acts on a particular body, even the frictional resistance proportionally increases. Both will increase proportionally till the limiting friction point. Once limiting friction point reaches, friction resistance cannot increase further, only the applied force increases and body starts to move. And body starts to move. And body starts to move. So body starts to move when the applied force reaches limiting friction point. Till limiting friction point, as you increase the magnitude of external force, even the magnitude of the frictional resistance offered by the surface will increase. Let us try to understand this concept in detail. Let us try to understand the same concept. Hope you are clear with the concept, but still, let me explain the concept in detail. Just a second, I'll share the screen. You have a small video here, a small video which you, if you go through this, you'll understand the concept. Just observe the video. Just observe the video. It will play back once again. You have a body and you have a lorry or truck which tries to pull. See, it increases the force. It tries to pull, but when it tries to pull initially, even the frictional resistance offered by the surface, FA, it increases in the opposite direction as it tries to pull. As it tries to pull. But at a particular point, the body starts to move. At a particular point, the body starts to move. So this particular point is called as limiting friction point. You can observe the graph. You can observe the graph as well. You can observe the graph. So when you observe the graph, see, graph proportionally increases till a particular point. See, it started increasing, Fs. It started increasing. It's increasing still. And at a particular point, it breaks. It breaks and the body starts to move. So here in the graph, x-axis will be the applied force and y-axis will be the frictional resistance. Y-axis will be the frictional resistance. Till a particular point, you see that particular point as Fs max there. Till that particular point, as you increase the external force, even the frictional resistance increases. So when that particular point is reached, the body starts to move, and we call that particular point as limiting friction point. Limiting friction point. The same concept which we discussed just now is being shown here. It is called as limiting friction point. Hope the concept is clear. Hope the concept is clear. You can observe the video here. Now let me show one more video of the same type. See here, the push becomes 2.5, 2.6. At 2.6, then the body starts to move. Just observe the video properly here. So initially push will be 1, 2, 2.5. When push increases, push will be the external force. When push increases, when the external force increases, even the frictional resistance proportionally increases. Still 2.5 newtons, but beyond 2.5 newtons, it cannot increase. In this particular example, beyond 2.5 newton, it cannot increase. In this particular example. So 2.5 newton will be the limiting friction point, beyond which, as you increase the external force, even though it becomes 2.6, frictional resistance cannot become 2.6 because the external force has crossed the limiting friction point and it has already overtook the frictional resistance. That's why body starts to move. Body starts to move. So this is the concept of limiting friction point. Hope this particular concept is clear. Now we have to remember several things here. The first concept which you are supposed to remember is to mark the frictional resistance. Frictional resistance will always be tangential to the surface, and its direction will be opposite to the direction of motion of the body. Direction of frictional resistance will always be opposite to the direction of motion of the body. This is a general concept, and you should know how to mark friction resistance. So frictional resistance will always be tangential to the surface, and its direction should be opposite to the direction of motion of the body. Direction of motion of the body. Direction of motion of the body. Now, sometimes there are chances that you may mark the frictional resistance. You may mark the frictional resistance opposite to the direction of applied force. Opposite to the direction of applied force, which is wrong. So direction of frictional resistance will always be opposite to the direction of motion of the body. If the body moves horizontal to the right, then the frictional resistance will be acting horizontal to the left. If the body moves horizontal to the left, then the frictional resistance will be acting horizontal to the right. So direction of frictional resistance will always depend on the direction of motion of the body, not the direction of the external force. It won't depend on the direction of the external force. It depends only on the direction of the motion of the body. So this is a small introduction to friction. And the theory of friction. You have a number of other concepts related to theory which we'll be covering in the next video. So please go through this properly. The entire section is available in the notes as well. You can go through the notes and try to understand this particular concept of limiting friction. We just went through the concept of limiting friction. The first part in the theory, in friction theory. Try to understand this. We'll be continuing the concept in the next video. The theory concept in the next video. Thank you.